AP Chem. This is part of your notes packet on thermodynamically favored reactions or spontaneous reactions. This is question 7. I'm going to do 7 through 10, I think, but partially, a little bit of 7. So one thing's important. Simplifying reaction, delta G. When you see this delta G, that means at standard conditions. So there's your equation for that. Remember, you're always trying to figure out is delta G positive or negative. Gibbs free energy is delta G. When it's negative, that means it's thermodynamically favored. Positive means it's not thermodynamically favored or spontaneous. When you see this little degree sign, that means at standard conditions. What that means is the concentrations of ions are 1 molar and pressures of gases are 1 atmosphere. So at standard conditions, 1 molar concentrations, 1 atmosphere pressure. So you could find delta G at different conditions. There is an equation. Delta G at non-standard conditions equals delta G at standard conditions plus RT ln K plus RT natural log of Q. We're not going to use that equation. We don't have to do this anymore. But I just want you to know there is a difference between standard conditions and non-standard conditions in these reactions. 8 is an important question. So how is delta G related to values of K? Remember, K is your equilibrium constant. When you have something in equilibrium, like your products over your reactants. So there's an equation for that. Delta G standard equals negative RT ln of K. Okay, remember K could be K in terms of pressure. I'm just going to put a little KEQ. Could be Ka for an acid, KSP, Kb for a base, something like that. Our R value in this equation, R value is 8.314. And this is off your blue sheet. It'll say it like this. So that means joules per mole per degree Kelvin. Joules per mole per degree Kelvin. Joules per mole per degree Kelvin. It's not saying KEQ, it's saying per degree Kelvin over there. So that is your R value in that equation. What I really want you to know is this. When delta G is 0, change colors here. When delta G is 0, that means K is 1. Okay, your equilibrium is 1, and we're at equilibrium at that point in time. Natural log of 1 is 0. Natural log of 1 is 0. So if you put a 1 in right there, that does make delta G become 0. If delta G is positive, so greater than 0, delta G is positive, greater than 0, that means K is less than 1, and we are not at equilibrium, okay, which means we are non-spontaneous or not thermodynamically favored. Non-spontaneous. I spelled that wrong. And then if delta G is negative, that means K is greater than 1. It is a thermodynamically favored reaction or a spontaneous reaction. So you can tell thermodynamically favored or not thermodynamically favored by your K value or by your delta G, your Gibbs free energy. All right. So that's what we're going to try and figure out the delta G of this. And is the reaction spontaneous? It's giving you the KSP for sodium acetate. So it's saying we have some sodium acetate, Na2C, H2C3O2. Surprised it has a KSP actually, forming some Na plus C2 H3O2 negative. This is your K value. So I'm trying to figure out if it is spontaneous at this point in time. So delta G equals a negative RT ln of K. In this case, it's KSP. Equals, our R value is 8.31. Negative, so there's negative out in front of here. 8.31. Remember, that is joules per mole per degree Kelvin. 0.3145 joules. We are at temperature would be 298 Kelvin, and the KSP is 2 times 10 to the negative third. Whoops, I forgot my natural log. I take natural log of that value. So times ln of 0.002. That's just the KSP. You type that in your calculator. Your delta G is 15.4. That's kilojoules. I changed it to kilojoules. It comes out in joules. I changed it to kilojoules. That is a positive value. So this is not spontaneous at that temperature. You have to heat it up probably to get it to there to be spontaneous and happen. Not spontaneous, which we would have known because our KSP was less than 1. Less than 1 means non-spontaneous at that point in time. All right, one more question here. Given this information, we want to figure out delta G for the reaction below. We've done this several times in different formats. So what is the delta G for this reaction? Given that this happens in a series of steps, we're trying to figure out what the delta G is there. So we need to get these to equal this. Well, we need carbon monoxide on the left, so we need to flip this one, and you flip that one. So that will change that sign to positive. If we flip this around, that's going to become positive. And then, so we'd have CO forming C plus a half an O2. And I think that works out. That gives us a mole of CO. Our carbons will cancel. And we're going to have CO2 there. And our oxygens would be a half on the left. That's what we want to have. So that equals that. Then we just add those together. So a negative 394 plus a positive that. This delta G then for this overall reaction would be a negative 257.2 kilojoules. So that means this is a spontaneous reaction. This one would be non-spontaneous. That's spontaneous. This one is